Okay, so I've got my levels set up, and so I forgot to grab your screens. Let's do that. So the reference planes, of course, coming up in my elevations as well, and you can see those, and then of course the levels. And then when we go back to the plan views, I'm going to go to the ground floor plan to draw my walls, because if I go to the site plan, it will actually put the walls in at the same height as if I was in the ground floor plan. But of course we can see that topography, and I don't want that getting in the way. So I'm going to go to the ground floor plan instead. And then I am just going to go back and look at this drawing so that you can just see the wall thickness there. You can see it's 250. So that means we need to make that wall type. And so clicking on the wall button there, I'm going to choose one to start with. So any of these generic walls will do, because we're going to change the height, or the thickness anyway. So it doesn't matter which one you choose. I'll choose generic 100, doesn't matter. And then I'm going to go to edit type and duplicate. So that's a process you need to get used to, and something you do all the time using that duplicate option. Oh yes, I'll just show that again. Okay, so once you start drawing your wall, you'll get in properties the option to choose your wall type. So again, just any of those generic wall types, doesn't matter which one. And then you can click edit type to make a copy of it. So you use duplicate, and I'm going to call this existing 250 mil. Now, actually, just on the side point, do you know what that means? If it's a 250 mil wall, what sort of construction do you think it might be? Definitely double brick. But then, so how thick is a brick? Thick as a brick. Yeah, 110, that's right. So 110. Yeah, no, so 110 is right. You can't get the 150s, but a standard brick is 110. So if it's 110 and we've got two of them, that's 220. That's right, so the mortar is 10 mil. So how are they getting that 250? Well, that's right, you'd think there would be a cavity. Normally there is, but it would have to be a thicker wall. It would be 270, and that would mean you'd have 110 and then a 50 mil cavity and then 110 again. That's right. Well, in some cases, but in this one, I'd assume because of the age of the building that they actually don't have a cavity. It's funny, cavity brickwork, I could be wrong about this, but I've had many architects in Australia tell me that it's basically an Australian invention, and it's spread around the world from Australia. I know, they had rain in Europe where they started doing double brick walls, and in fact it goes back to ancient Egypt. It's a really old thing doing masonry construction. But I think, well, the story I was told is that the rain wasn't as high pressure in Northern Europe. They must have had storms and things though, but anyhow, if you look at all the old buildings from before the 19th century, they generally didn't have cavities, and it was only, this is what I was taught at uni, when they started building cavity brick walls in Australia and getting picky about brick sizes and doing standard bricks, that then spread back to Europe, and they started doing it everywhere. So, yep, one of the few things that was actually invented here. Yeah, that's just what I was taught. And but having said that, I have seen old buildings that pretty much had a cavity, even though it wasn't called cavity brickwork. I've seen buildings in Europe and even in other parts of the world that seemed to have a cavity, so I'm not so sure that it was really invented here, but definitely the practice of doing it as a standard thing did start in the late 19th century here, because you can see the buildings from this era, around the 1870s and before, were solid brickwork. And that was the technique imported from Britain, obviously, and those buildings leak like crazy. I know, because I own one, and we've had to do waterproof render to stop the walls from leaking. Yeah, that's right. Yep. And half of them, you won't notice the difference from the outside. A lot of the terraces, the really beautiful terraces, have solid brickwork. It's not a cavity. And you've got to do all sorts of crazy things to make them stop leaking. But that's a real giveaway. If you see a thickness like that, you can generally assume it's solid brickwork, so no cavity, and that means it is 110, then 10 mil mortar in between, 110 again, and then 10 mil of render either side. That gives you 250. Yeah. So 30 mil of mortar all up. So that takes it back to 220 and then 2 bricks. So that's your 250. So anyhow, it's always interesting to look at that. Whenever you're drawing an old building, you can usually tell almost instantly whether it's from the middle of the 19th century or the end of the 19th century just from the wall thickness. Yeah. So I've given it a new name. It's called Existing 250, but it's not that thickness yet. We need to click Edit next to Structure and then type in the thickness that we want, which is of course is 250. And then click on the coarse scale fill colour, because we're going to set the right graphics this time for existing versus new. So do you know what the colour for existing should be? Exactly. So black when it's cut in plan especially, or section, means it's an existing wall, and then your new walls can be coloured to show the materials. So that's it, and if we click OK, then on the options bar, just need to set the height. So if you remember, parapet is the height we want all of these walls to be initially, and then the location line, going to set to finished face exterior, and then click on the intersections of these reference planes and boundaries, and just go around drawing clockwise to draw all of those exterior walls, following the reference planes that we've already set up. And how easy is that? Into 3D, and we've got the building. So doing all that setup makes it much, much easier when you go to set everything out. So that's it. That's going to give you the walls, and those will be the exterior walls that you'll use all the way through.